Okay.
It says it's being live streamed, so I think we're good. Let me move this over somewhere else. Make sure I can see our participants here. Okay. So let's go ahead and get started. So today I'm going to talk about application insights, as you, I'm sure, inferred from the title of the presentation. Now, what exactly is application insights? So we'll start here. Feel free to ask questions at any point. You can put them in chat if you want. You're welcome just to get on audio, ask the question there. I am fine with everything, and my main goal is to help you learn what you came here to learn. So I will talk about all the random things that I know about the subject if you don't ask about something specifically that you care about. So might be useful to you, might not, we'll see. Application Insights is designed for application performance monitoring. So it can tell you how long your web pages take to load. It can tell you how long your backend service takes when processing requests. It can tell you about the calls to the dependencies. And then all of that information is available within the Azure Portal UI. Now, we'll be looking at all of this soon. We're not going to spend very much time at all on like slides. Rather, we're going to jump right in and we're going to run with it from there. So I'll just point out a couple of the other things here. There's some alerts that you can use. You can export your data, be it Power BI. There's integrations with Visual Studio. And then there's something called continuous export. If you want all of your data to go somewhere else, like a storage account or Event Hub, you can send that data elsewhere at the same time as you're receiving it in your application. So with that, all of the code that we're going to be looking at today is on GitHub. I made this public as of like 20 minutes ago, so right before the presentation today. So I will be looking at this project and solution. The docs are still kind of sparse, but there is a number of to-dos in here that kind of document the process, and that's what we're going to be covering today. So before I just kind of jump in and look at code, I want to give you a little bit of an idea what it is that the Azure portal looks like. So here is the Azure portal for application insights. And as you can see, there's currently 0 traffic. I don't have my application up and running yet. If I do, extend this a bit, you can see I have been playing around with it. So we have historic data that we can look at. And we're going to actually bring up some live data here shortly. So with that, let me jump into the actual code. Let me go find the application. Okay. So I'll be using Writer. You can do this in Visual Studio. There's nothing specific to Writer except for I'm on Linux. So Visual Studio isn't an option. So with that, this is an ASP.NET Core / .NET 5 application. So if we were to come over here and look at the project properties, what we're going to see is this is .NET 5. It says it's console application. The reality is this is a web application. So I took the standard .NET 5 ASP.NET project. I started with that. And then I added some basic functionality. So this is going to kind of act like a e-store, right? So we have a cart, and which we can see here. So we have items that we can add to our cart, and then we have a cart controller, which has a few methods. Like we can add something to our cart, we can retrieve the items in our shopping cart, and actually that might even be it, just those 2 methods, and then there's a bunch of code to go with it. Okay, so in order to actually have some useful data, let's go ahead and start up the app. We'll talk a little bit more about the application and how it works. Okay, so here we have it running. Now, in order to generate data, we need something that will give us load. Now, okay, so it doesn't like that. That's fine. Okay. So I pulled up JMeter, and I'm sorry I can't make this a lot larger in terms of font, but JMeter is a load testing tool. It's one that I used at a prior job, so I'm familiar with it. If you happen to use BlazeMeter, then you'll know that BlazeMeter, which is a load testing as a service site, it allows you to upload these JMeter files, and then it handles the data collection side. So it handles the running. So although you have a nice UI here, or a relatively nice UI, there are some limitations when you try and run it through the UI, and that is you're sacrificing some of the time and the consistency that you would be creating load to update the data that you have here. So for example, there's this report here. In this case, this is a table. I have 0 data because I haven't ran it yet. Same thing with the graph. There's nothing in the graph yet. So if I start running the UI has to stop. It has to do work, and we're now consuming some of the precious thread time. So something like BlazeMeter does a good job of distributing this load and then, like I said, gathering the metrics. So with that, we're going to go ahead and just take a look at this. So right now I have this set up with a single user. That's not much traffic. So let's go ahead and bump this up. And it's going to go through, and it's going to go ahead and first it's going to retrieve a cart. In this case, the cart is going to be empty. And then it's going to go ahead and post this JSON saying, hey, I want to add this item to my shopping cart. And then and I am emulating user delay, right? So there's a wait for 1.6 seconds, right? Then I go ahead and add an SSD and a DDR4. And then I might just randomly choose one, right? So not every user is going to do the exact same thing versus some realism. And then I'm finally going to go ahead and get a cart. So with that, I'm going to go ahead and disable this because that one will collect and use lots of data. So let me go ahead. All the data is cleared, and I'm going to go ahead and start running. And what we should see is that my application is going to start accepting traffic. So if I scroll down here, if I can get to the bottom, now we can see that, yes, it is accepting requests. There is intentionally some errors that are occurring here. So we can ignore those for now. We'll be looking at those within the App Insights UI. Okay, so now we have some data here shortly. We will be able to see that data within the Application Insights user interface. And for now, we're going to jump back to the program class, and we're going to start looking at these to-dos. These to-dos define, I'm hoping, let me move this down. Okay. And I have lost my menu, which might be related to me sharing the screen, but I'm not sure. Okay. So we have looked at the basic structure of the application. We've seen the controller. So here we have an application, and this application does have health checks are available. We didn't look at those at all, but they are there. And then we have Serolog logging. So this is the background or the starting point for the application. So now, assuming that I want to jump in so that I have application insights available, the first thing that I need to do is install the Microsoft Application Insights ASP.NET Core NuGet package. Now, I have already done that. So if I pull up my NuGet console, you can see that I do have a number of application insights packages, right? So I have ASP.NET Core. And then you'll notice that there is these implicitly installed dependencies. So it does depend, well, not just this one, but between this package and the others, there are a number of other packages that were pulled in that I didn't explicitly install, but will be automatically installed for you as dependencies. So first thing, so we have to install this NuGet package. That is going to give us the core functionality that we care about. So once we've done that, we're going to go ahead and jump over to step 2. So let's see what step 2 is. Step 2 is we need to add our application insights telemetry. Now, what this is going to do is this is going to register the default modules that control what App Insights is going to record and how often it is going to send it to Application Insights. So with that, let's go ahead, let's take a brief reprieve. Let's come over here. I am going to refresh this, see if I have an individual refresh screen. I could probably just change this here. I'm not seeing the data there. I've ran through this lots of time. So we have lots of successes. We have one that's failing a bunch. That's interesting. And it did stop running. So let's go ahead and let's try something slightly different here. So we saw the errors or the content in the log, and I'm going to go ahead and fire this off again. I thought I had it set to run. Oh, I did not have it set to run forever. So there's very minimal traffic. That's why I missed a checkbox. Okay, so one of those modules that I was just telling you about where we have the ability to say, hey, this is default data that I want displayed is one that enables a live view of traffic. So we can notice that we're starting to see some memory go up. And if I look, the error rate is actually really high for some reason. So something happened and the application is doing something funny. So I guess we'll have to take a look at that. I don't want to jump too far in there yet. So let's go ahead. We'll go back to 7 days and let's just pick one. So we can go to server requests and we can pick a time interval that we care about. So I'm just going to select a time interval when I was running a load test, and we'll zoom in a little bit there. And then we can see down here the different requests that were made. So we saw a bunch of requests, or a few requests, 11 to Swagger, but then we have 3.5 thousand for adding items to our cart. And we have 1.6 thousand here for get items. And for each of these calls, we have a histogram of the duration. So for example, I can see that most of the calls were completing in this 14 millisecond period. But there were some that took longer over here with a lot actually completing almost instantaneously. So let's go ahead, we will zoom in. And now that I've zoomed in on a specific time interval, I can actually start looking at the samples. So I can come here and I can say, oh, hey, here's the request. This one was 455. Ooh, let's look at that one. That doesn't sound good. All right, that took a long time. So I get cart items, and then I have a dependency. Now, I did not build out a long dependency graph because there is just not a lot of value in doing that for this demo. But what we would see is we can see a high hierarchy of calls. And there's a couple of cases later where we'll see a slightly more nested hierarchy. Okay, so here we have that, right? So we can see the data within the UI. We can look at samples. We can drill into both the requests as well as failures. So I'm going to do the same thing for failures. We'll zoom in a little bit more. Okay, so there's the graph. And I can see that, oh, I returned a number of 500s, like 17,000. And then, 37,000 argument out of range exceptions. That seems like a lot, right? So I can click on one of these. And once I have done that, I get kind of the same interface. And then I'll just click on that. And now I can see here's the post that was made. And I have some properties about the exception. So this particular request returned to 500. If I scroll down, I can get information like, hey, this was the machine that it was running on. This is how often it was, or either the number of samples, or the rate of samples. I actually haven't seen sample rate before. And I can use this to start troubleshooting and debugging. And I'm avoiding some of the functionality that would be useful in understanding this for now, because we're going to get to that. If I click on one of these exceptions, we actually get even more details. So this one is interesting. Could not find a suitable shadow copy folder. So this is actually just from a little bit ago, it looks like. So for some reason, my application is having a hard time with the snapshots. So that's interesting. We could disable that. So maybe we'll use App Insights live today to troubleshoot what's going on with the app. Anyway, that's kind of fun. Okay, so now we've seen a little bit of how this fills in the UI. So the standard data that we're going to have is failed requests, server response time, server requests. Availability is a standard metric that is displayed in the UI, but it is not bundled with the functionality that is provided here when we call add application insights telemetry. So the availability is not going to be populated by default. You do not need to specify any options at all. However, you can, right? So I can have the application send to heartbeats, which would allow me to write a query or an alert saying, hey, is my application still running, right? If it stopped sending the heartbeat, and then when my query ran, it didn't find any results for that last, minute interval or something like that, I could send an alert to myself, be it email or text message or something like that, to let me know something was wrong. Okay, so that's step 2. So now that we have application insights telemetry set up, the next thing that we're going to need to do is we need to define some settings. So let's go ahead and let's look at our app settings JSON file. So there are 2 different mechanisms that you can use to connect to application insights. One of those is an instrumentation key. The instrumentation key was the first mechanism that was introduced. So this GUID allows me to send messages to this particular application insights instance. And then later, they introduced the idea of a connection string. And the connection string is more robust in that it allows for them to specify exactly where the messages should be sent, and some other things like that. So some of the newer Azure regions actually require that you use a connection string, and they cannot accept or messages that are only using the instrumentation key. So in general, always use the connection string now. And I just documented that here in this comment tag. So this is not something that exists within the application insight structure. There are other elements that you can specify. I chose to set them in code, but for almost all of them, you can set them right here within the application insights section of your app settings JSON file. So let's go ahead and we'll jump back now. Okay, so we have our settings, we have a connection string, and an instrumentation key so that my application knows where to send all of the messages. So the next step is to ensure that we're actually tracking something that is useful. Now, there are some things that are going to be tracked by default. And in order to do that, or to know what those are, we can just Google application insights default publish telemetry. Let's see which one. Hopefully I can find this one right here. I should have grabbed that page earlier, but there is a page that shows us. Now, I did not set the application up to present a UI. So you can have application insights track like JavaScript, web page views, and things like that. And just given the need to be somewhat concise in the presentation, I thought that was a little too much to do. So that part is not configured in my application. because I didn't even bother creating a UI. So we're only background. So here's these default options that I should say most of these are default, right? So there is a couple down here that are not. So performance counters. If you're on Windows, then by default, it will collect your basic performance counters. So CPU, memory, number of garbage collections, and things like that. It is very useful to have that information available. Request tracking. This is for the ASP.NET Core pieces. So it's going to hook into the middleware, and it is going to pay attention to all of the web requests or API requests that are coming in, how long they take, whether they succeed or they fail, whether they result in a 200 or a 400 or something like that. So this is one that if you're running ASP.NET Core, you're going to want to leave enabled. Okay, event counters. Event counters are I'll say cross-platform version of performance counters. So if you are on Linux or like Mac or something else, you're going to need to gather the CPU information, the memory information via event counters instead of performance counters. So they're both enabled, but note that some of these are platform specific. So this one, yeah, it's enabled by default, but it's not going to do anything if you're not on Windows. Okay. And then there's some of these other modules here. I might come back to some of these, but know that those are the core ones. The last one that really matters is dependency tracking. So just because it says dependency tracking doesn't mean it's going to track everything. However, it does do a really good job at tracking, kind of the core things that you would expect to see in your application. So it tracks a number of the Azure components. It tracks your HTTP dependencies. So if I make a web request out using HTTP client, it's going to automatically track that without us doing anything at all. Okay, so let's jump back here to the code. So here we have a random number provider, and I wanted to demonstrate manually introducing and tracking a dependency that otherwise would not be tracked by application insights, right? So this is some service that I created, it's a dependency, and I wanted to explicitly call out that this is a dependency so that it would show up. So here we have this dependency tracking random number provider. The approach that I took, as I mentioned up here, is that I wanted to create a decorator. Now, a decorator is a service that provides the exact same interface as some other service, only it provides additional behavior. So typically, we would register something like this, right? Like, hey, I have this interface, random number provider, and here's my concrete implementation. So this is what I would have had if I decided I didn't want to use dependency tracking. The way I wrote it is I set up this decorator, which we could look at here shortly, that takes in the original random number provider that would have been provided right here, right? So this is the exact same type. And I use the provider here to provide the dependencies to this random number provider. Okay, so with that, let's look at this dependency tracking random number provider. So what is the process of actually tracking a dependency? Knowing the decorator pattern, this is going to take the original one, the decorated instance, and it is going to add additional logic. That additional logic is going to use this telemetry client. And if I hover over this, we can see that this comes from Microsoft Application Insights. So with that, let's go ahead and take a look at the implementation. So the implementation of my get random number up to some max value is to start a timer. I assume success by default. Then I call the original one with that timer running. So the timer is running. I get my random number, and then I will set my false flag if I need to. But then I stop the timer, and I just call telemetry client from App Insights track dependency. And there are other approaches. If we don't run out of time, we will see a couple of those a little bit later. But now this information about the call, or I should say the type of the dependency, and the method that was called, along with the data that we decided to take, is then sent up to App Insights and recorded so that I can see this within the dependency view. And we haven't looked at the dependency view yet. So let's go ahead and we'll jump over there really quickly. If I can figure out where my window went. Too many windows. Here we go. Okay, so I'm going to go back to the portal. If we look at server requests, let's change this time to 7 days here. Let's go ahead and zoom in on one. This one may have been before I implemented the dependency tracking, so I guess we'll see. So now let's just go ahead. I don't know, one of these slow ones seems like it could be fun. So we'll pick one of those. I have 545 samples. So let's just pick one and let's see if we have the dependency here. So this isn't showing the dependency. Like I said, I should probably choose, to be sure that I had implemented it, a time period. So let's go here. And then here's actually a dependencies view. And yeah, this isn't showing it for the given time interval. So I'll need to change the time interval to something other than the last hour. And let's go to yesterday because it was in place yesterday. And that should be good enough here. Okay, so now under the dependencies tab, I can see that I have a couple of dependencies. And here's the one that we were just looking at. So random number provider. Let's go back to the code, right? Say random number provider here, and then we had get random number up to, and we can see exactly how long it was taking. Now, if it's going to be this fast, yeah, maybe I don't need to track it, or maybe it is still important. But here we have insight into those dependencies, and we can drill into them at the histogram level, which can be very useful. Okay. So with that, we have, let's see if I can jump back here. Okay, so we've now gone through, we have added this random number provider. So we're tracking dependencies. And now we're going to move on to another step. And this particular step introduces this idea of telemetry initializers. Now, I didn't mention what the telemetry client is other than saying, hey, this comes from the Microsoft Application Insights assembly here. And there are a number of interfaces that can be implemented that are extensibility points. One of those extensibility points is this telemetry initializer. And this allows us to do certain things. Now, you'll notice here I have a thread details request message telemetry initializer. That might seem like a long name. First, let's go ahead and let's look at this interface. So the interface is super simple. It is simply initialize and you get an iTelemetry object. There are a number of different implementations of this. And the reason my initializer has the word request in the name is because, oops, did not mean to hit that. It is going to operate on this request telemetry right here. So I'm going to go back and now let's go ahead and look at this. So this initializer is one that adds thread information to the request. So by default, we saw a number of those properties when I was kind of viewing through the UI that demonstrated what is captured automatically. But I decided for some reason that thread ID was important to capture. So I took the telemetry interface. I made sure that it was of type request telemetry. And then I set some properties to set both the thread ID and the thread name so that if I look at the metadata within the logs, let's go ahead and pick one. Let's drill into one of these samples here. And I just picked a random one. So I'm going to do show all. And I should have, assuming that I have implemented it at this time, custom properties. So this one, doesn't look like it does have it. Actually, no, I'm looking at get random number. This is not a request one. This is a dependency one. So I'm not going to see it on this particular one. So I need to go back. Let's look at server requests. Operations is good. I need to change my time to, we'll do last 3 days here. Let's zoom in. I will pick an operation. This is a request, right? A post is a request. I have 44,000 samples. And okay, so here is my thread ID. The thread name, you'll notice, is not present. If it's blank, it assumes there's no value in having it. So you might want to set none or something like that if it's important. But here we have the recorded thread ID. So if I suspected there was a bug that was specific to like a thread, or a thread got into a bad state, that might be information that I wanted. So here we can see those custom properties, as well as some of the default ones that were automatically provided by the request middleware. Okay, so we've seen one extensibility point, this iTelemetry initializer. There are a number of others. One of the main ones is this iTelemetry module. So when we were looking at the application insights, the default modules, what we saw was basically a list of these different modules. So now you'll notice there's a few other things, processors, we can talk about that a little bit later. But each of those is a module, and a module is simply a collection of code necessary for application insights to gather a certain type or subset of data, right? So diagnostics telemetry module, for example. What it does is its whole purpose is to look at the diagnostic data being sent through logs, typically your event sources, and to gather those so that it can record that information within application insights. So there are a number of other modules that can be enabled or disabled. We'll get to that a little bit here. And let's go ahead and continue on. So I am moving a little fast. Haven't heard any questions. I haven't seen any in chat. So feel free to, like I said, post anything there. Again, jump in with questions. Ask right now if you have any. Otherwise, we'll just continue on. Okay. By default, the availability that we saw within the UI right back here is not populated. And that's because Application Insights doesn't know how you're going to measure availability. Now, the mechanism that I am using today has some weaknesses. So let me go to, now you can see that the dash line basically means I have values after this. So that's why it's dashed here, bolded here. So I'm going to go ahead, I'm going to click on availability, and now I can zoom in. It is telling me that this is something custom that I did. And if I click in for this time interval, this is the service ID or name. So if I had my, if I had another box or machine running at the same time, if I had 4 different machines, I would see 1 for each server here. And I can see that it is at 100%. I can click on that, and again, I can drill into my samples. And we have the option of recording extra things. I'll just put it that way, right? So I can see here in my custom properties that I'm operating in developer mode. I can see how long my health check took, which was very little. And I can add each of these to that. So that's what we're going to go ahead and look at now. Now, the weakness of this particular approach is my application is running, and I set up a periodic health check. So if I were to go, and I think I have that in my startup file here. So let's go and look at my startup. And if I look for period, I can see that I have the health check publisher options set. I'm going to wait 10 seconds after my application startup, and then every 30 seconds, I am going to run this particular health check. So like I said, health checks are running every 30 seconds, and I'm using this to actually record availability. So to go back to our code here, the Application Insights Health Check Results Publisher is configured to handle those results. So it's going to do that, it needs to implement this iHealthCheck Publisher interface. And then it has to implement, therefore, this publish async method. So what this does is this gets a health report that was provided by ASP.NET at the time that it ran those health checks. And then what I chose to do is to say, hey, let me create my availability telemetry that I am then going to report. So I have this telemetry here. Let me go ahead and highlight that. And then I'm going to go through each of the entries in that health report, and I'm going to add some custom properties where those custom properties are based on the particular key or particular health check that was run. So when we were back here and we saw dependency health check, that's just a health check that I chose to write. So we could go ahead, we can look at my dependency available health check here, and we can see that it's attempting to resolve a service. And if it's null, it errors out. Otherwise, or throws an exception, right? That would also error out. Otherwise, it returns healthy. So this health check makes sense. And that's why the name showed up there. So this way, my application can self-report on its status, or in this case, it could be the status of its dependencies or other things like that. Okay, so by introducing the iHealthCheck Publisher, we saw that we're able to take the telemetry client and track availability information so that we have it here within the UI. And let me go back actually. So we could see how it was. Again, my time interval is off. That's all right. Okay. So I think that was like step 7. So let's go ahead and now we need to find step 8. Okay. So step 8 was to enable the Application Insights Profiler, and specifically the ASP.NET Core one. Now I'm going to make a quick change to the application to hopefully make it so that I can actually run this. So I strongly suspect I know what happened, and it was a hardware/machine change I made yesterday that broke that shadow copy folder, and I don't know exactly where that was configured or why it's not recreating a new one, because I don't remember ever explicitly creating it. So okay, that's all right. So let's go ahead. I'm going to go back to my startup here. And down in these later steps, okay, here's the service profiler. And what I'm going to disable, is the snapshot collector here. So let me do that. I'm going to run a clean. I'm going to run a new build. Both of those are done. Let me go ahead, fire up the application, and then I'm going to go ahead and I'm going to fire off that load test. The load test is now running. Okay, so with that, we're going to jump back into the service profiler part, and then pretty soon, hopefully, we should have some live data that we could look at. Okay, the service profiler. The service profiler allows us to sample stacks of the application and see exactly what code is making our application slow. So let's go ahead and let's look at some more of these samples. So the first thing that we can do, and I'm going to do just a quick check, hopefully the application's not erroring out, is see if my load test is now streaming data. And it is. So we can see I have requests coming in. I can see how long they're taking, and I can see how long the dependencies are taking. I can see failures. I don't have a lot of them. Looks like I can, now that we have this running successfully, I'll probably ramp up traffic a little bit. So we can look at something a little bit more substantial. So I'll pull up JMeter here so you can see me on screen. I need to go to my virtual users. Because I have the user thinking, I'm going to go ahead and just bump this up a lot. Right now it's going to go on forever. That's probably a little excessive. So let's go ahead and I will do 30 times per user. So it's going to go through all of these steps 30 times for each user for 200 different users. Okay, so and pretty soon I should see data start to climb back up. Okay, so back over to the service profiler. So this is going to be useful as we're starting to take a look at things. So going back to my dashboard here, I'm going to go to my, let me go to yesterday. It inherited that time. Okay, and here are the slowest ones, right? So typically, if I care about performance, what I'm caring about is what's going slow. Let's see what's going on with this. And hopefully this is the one that has the data that I care about. Okay, so here is that hierarchy that I mentioned for our dependencies. So we can see here's, and I didn't show you where this one came from. I did show you where this one came from, right? This is the iRandom number provider, but I don't have, you'll notice I don't have like stack information. We did see a little bit on the snapshots. I shouldn't say on the snapshots, on the exceptions, but that's slightly different. So let me go back here. And hopefully, it's not here this time. Let me go to server response time. Let's select it here, drill into it. And hopefully one of this will, if not, we'll go to it a different way. Okay, so a lot of times you'll have data. Now I've been turning things on and off, so it's not surprising that it's not there. But normally I'll have a little box here that allows me to get to the profiled data. In this case, it's not there because the sample doesn't have it. I did notice it in a couple of the other ones, but let's actually just go to we'll go back to this response time, and I'm going to hit the profiler here. So I can go directly to it if I want. Now, for this to be present, let's go to, sure, last 7 days. Okay, so here are a number of different profiles that I've captured. And I haven't even looked at these yet, so we're just going to pick one. And what it's going to do is it's going to analyze the data gathered via the .NET counters. So the .NET counters and some of the profiling pieces are going to go through. They're going to grab stack traces, and they're going to give us good information. So looking at this, I can download this and load this into Purview. I think that's all I'm going to say about the top part now. Okay, so here is our timeline, right? So this timeline represents the total duration for this uppermost request. So as long as these bars are all about the same, then all of these methods are taking about the same time. So I haven't yet got to the method where I spend all the time. So I'm just going to scroll down at the first one, or the last one, I should say, with the bar. The first one without indicates the time that I need to start looking. So apparently, I spent all my time on a wait time. So I have this cart controller, required item delay, async here. So let's go ahead and let's look at the controller and let's see if we can figure out. So we're on it in an await in required item delay async. So let's jump back over. Let's go to our cart controller and let's look at our required item delay async method. And sure enough, it takes a cart. Look at that. Okay, if the cart ID is less than 50, this is totally not realistic, right? But hey, it's a demo. It's going to wait for 50 milliseconds. If the cart ID is less than 1,000, it'll wait for 100. But if it's less than 2,000, it'll wait for 300 milliseconds. So that's exactly where our delay came from. And sure enough, it was accurate, right? It identified the method. We did have to make a few inferences, but it did discover that the delay is there. Now, I actually found a bug when I was doing this POC. I emailed Microsoft Friday night. Monday morning, they got back to me. I gave them permission to look at the data because in case it was confidential, they didn't want to look at it without permission. And by yesterday, they got back to me letting me know they have fixed the bug, but it's going to take about 3 weeks before, like end of sprint and everything gets pushed out. So here within about 3 weeks, that bug will be fixed. And in addition, I'll just note that they are currently doing a preview, a limited preview of some more advanced functionality to make this even easier to understand. So cool stuff is coming. Okay, so here we have the service profiler. We were able to view it. We were able to see exactly where my code spent its time. There are a couple of options that we could use for controlling the service profiler. So I actually have it disabled right now. Right, so I'm not going to see it for current ones. Right, I can configure whether I should gather that information as soon as I hit that trigger percentage. I can configure how long it's going to grab a sample. I can configure other things like how often it's going to run them. Okay, so that's step 9. Let's jump over to step 10, wherever that is. Oops, step 10. There, step 10. Okay. Oh, the snapshot collector. This one is also very useful. If you're running the profiler, then you're going to get much of the same information that you do here. It is not entirely the same, but you do get those stack traces. So let's go ahead, let's go back to an older time and let's find failed requests because that's where we're going to see our snapshots. So the snapshot collector is this snapshot debugger piece right here. Now, it is going to take snapshots of errors and it is going to record them right here. So you'll notice for the last 24 hours, this upload or start exception, this is it failing. That's why I commented out earlier today. Again, that's my machine change, that's an issue. But it is going to record the stack trace for every exception. So I'm going to go to this one because I care more about things that happened yesterday. Hopefully I have one here. And notice I have this snapshots only. Okay, so I need to change my time interval so I do have it. So let's go to last 3 days. Oh, last 3 days, apply, there we go. Okay, so now I can say snapshots only. And now for whatever restrictions I have, I can view those that have snapshots provided. Now, there is a module that I didn't talk about that says, hey, I'm going to sample. So it's not going to gather every single stack trace. It's not going to gather every single request that comes in. And we haven't looked at the data model yet. Judging by time, we're not going to have the time to look at the data model behind application insights. But know that you can write queries against it yourself, and the query language is quite strong. Okay, so here I now have the ability to open this debug snapshot. So if I click on this, I get this little icon right here that says I have a debug snapshot. I also get this little link up here. And I can view in, and if I scroll down, I do get a stack trace. So this is what you typically get even without the snapshot debugger. But what's really cool about the snapshot debugger is I can get quite a bit of additional information. And more specifically, I get the locals at the stack level, right? So if for these various stack frames, right? So I can see the data that was passed to these methods. In this case, I have, so this is to the function, right? I have this card ID that was passed, that was 2010. And if we think back at the sample code, sure enough, it said if the exception or if the card ID was over 2000 to throw an exception. And that was so we had actually had exceptions to look at. So here, we can see that this data was gathered and I can look at it. Parameter card ID must not be greater than 2000. And I could use all of this information here to troubleshoot. In addition, I can download this. And notice this opens in Visual Studio Enterprise. There is an extent, it's no longer an extension. For Visual Studio 2017, like the first, I don't know, I'll just say 50% of versions. Some of the early versions of Visual Studio 2017, there was an extension you could get for it that would allow you to open these files directly. As of more recent versions of 2017 and then 2019 and so on, it's built right in if you install that particular component. So I could download this and I could open it up right in Visual Studio. And we also have the ability, now that I accepted the agreement, to actually see decompiled code. Now, it is not as smart as some of the decompilers, right? So it is going to show me the state machine, your async state machines and things like that. That's not necessarily a bad thing. It's just really cool that I have this data right here so that I can tell what the application was done. And let's see. Okay, so Eric had a question. How do you prevent potentially sensitive data from being logged in the snapshot debugger? Or do you expect to use that in non-prod environments? Okay, so you're ahead of me, Eric. You're just too smart. So let's go ahead and let's go to step 11. Now, notice right here, so actually I didn't mention it here, it's right here, right? Because there is potentially sensitive data, we do need to add the application insight snapshot debugger role to the users that will need to access it. And they are pretty picky about this. I was an admin in my Azure tenant, and it would not allow me to see it without me explicitly adding this role to my account. So there are security precautions around it. Not everybody should have access to it because it is security sensitive. Great question. Okay, so step 13. And actually note too that there are some security precautions around the profiler. It's not quite as sensitive because it's not giving you all the local variables, but there are some security precautions that you should keep track of there. Okay, so earlier we looked at one way of keeping track of dependencies, but I do want to call out that in order for these to show up within the snapshot debugger, you have to explicitly track the exception, which is a little bit of work, but for the benefit that you get, right, there is excellent value. So by calling track exception here, by passing the exception, I did intentionally add, and this is where the, let's see, go back here. This is where this particular piece came from. I chose to add this value. The variables here are those that were automatically picked up. Okay, so this is necessary to particularly to track that. So let's go ahead. We'll jump over to step 14. We're almost out of time, and we're also almost done. Okay. Secure live metrics. So I did show you the live metrics view. We looked at that briefly. Figure out where my UI went here. Too many. Okay. So let's go back. We'll go back to that particular live metrics view. It's going to take a couple of seconds. While that's loading up, there are also some security concerns around this particular UI. And I did stop running the load test, so we're not actually getting any data. I'll go ahead and fire that off. The backend that supports the gathering of this data is only active when this page is being viewed. So in other words, I came to this page, it sent a request to my application, and I'm not going to go over the technical details on how, but it sent a request to my application that said, hey, start sending these live metrics. So there is a need to secure the control plane that says, hey, I'm going to send the request to your application. Now that is done at the application level by specifying a module authentication API key. So I was, actually, let me just show you really quickly. In order to do that, we go into the Azure portal. I'm going to go ahead and open up another one really quickly. So I'm going to go back to my App Insights test. If I scroll down to API access, you're going to see that I do have this key here. And I could create a new one. And when I do create a new one, I have the ability to say that, hey, this is what it's for. So that will allow me to make sure that it is fully secured. And as you can see, we do have this, nice graph. I have my load quest data going through, and I have all of this great data. And I can do other things like filter the data. But we're almost out of time. So let's see if there was anything else. Step 15. Nope, there isn't. So I do have some bonus stuff that we didn't get to. So we could look at these. So one other way is, besides using the dependency decorator that I demonstrated, is to say, hey, I want to start an operation. And by doing this, any child operations that take place, they're automatically added and nested. So this is where the second layer in that 3-layer dependency came from. It came from this particular operation. And then the random number provider, which was, if we go back to my implementation, was this dependency tracking one. It tracked that first, second, or whatever, the last layer. Okay, so that was bonus 1. Let's go up to bonus 2 really quickly. So we also have the ability to record custom metrics. Now I don't have time to go into too much other than you can choose you can choose to name your metrics. There are different dimensions that you can record. In this case, this is a single dimension, right? I don't specify any additional data. And then when you send this data, so if I look at my lazy metric here, I can call track value to record. Now, because some metrics are used for real-time analysis, they need to be very, very fast. And this particular metric implementation that I just showed you with a getMetric call is one that actually only sends the data to the backend once a minute. So it records information about the number of calls, about the total value of the calls of the data passed to it, right? So if I go back down and look at this, it's going to give me the sum of these values and a number of other things. And it's going to send that, like I said, once every minute. Because this data is pre-aggregated, it can be queried very, very quickly. It doesn't affect load, and you're not paying for a lot of ingestion costs. So with that, we've covered basically everything that I intended to cover. There aren't any more bonuses here. So with that, I will open it up to questions. And see if I can find the Zoom screen where I can see people.
Thank you, Caleb. I have a question on the usage costs for Azure to use these features. What typically would you expect? How is it gathered? Is it by amount of traffic used? How much you store? How does that work?
You hit both nails on the head. It is based on storage costs above 30 days and based on the amount of data ingested. So the longer that you choose to store something, the first 30 days is free, right? So that's why they automatically include that. But if you do anything more than 30 days, then you're going to pay additional for the storage based on the number of gigabytes. And we could go through and we could pull up the page for the pricing. We could argue that it's expensive or not, depending on the service that you use, but the functionality is great. One of the things that I didn't mention, and I'll just mention this because it does tie in with the costs, is I didn't look at traces here. So I'm actually, let's go to the log view, and there's a couple of other questions I'll try to get to really quickly here. So this is the backend data model right here. If we pull up this traces table, and I'm just going to grab a sample of 50 pieces of data, you can see where it's starting up the application. I guess I skipped that part, but there is a Serolog sync. So if I were to go back to my NuGet packages, we can see that I have the Serolog sync for application insight. So I installed this. That automatically gives me this trace data. This is typically where I see most of the storage costs come from. It's come from the logging of the application rather than in these other pieces of data, right? But that's up to you. You choose what you send. I could choose to limit what is sent. I could choose to sample more, right? So maybe you only send 5% or 2% of traffic, right? If you have a huge amount of traffic, you definitely don't need to sample 70%.
I have something else to add. I typically am familiar with Google Analytics, and it's more of a desktop gathering data of feature use
Mm-hmm.
for per user and capability of that feature use. And so we could track features that are popular for users or features that are rarely used. And also we could track workflow of a particular customer and kind of encompass all the metrics to do that. Is this a platform to do something similar like that for, let's say, a desktop application?
Yeah, absolutely. So you can use App Insights in desktop applications. You would pull in a different NuGet package. You wouldn't pull in that ASP.NET Core one. And you'll notice I have this users tab over here where I can get per user information. Let's see there. And you can see where I ran the load test. But typically in a real site, you'll have this up and down of users and whatnot. You can get the user flows and the cohorts. The user flow will be kind of interesting. Let's do get card items here. And this is much more useful in a real application than my sample one, but we can see, okay, so here's the event that I chose. I can see what they did before. I can see what they did after. And it actually, this bar here, let's see, I think I know how to write on the screen, right? This bar right here and right here, those represent the portion of the traffic that came from that mechanism. So typically you will have, let's see, there. Typically, you'll have a number of different entry points, right? And then they will lead to here, and then you'll have different exit points. So the graph is, like I said, in a real application, much more complicated, but does give you all that. The key for everything that you're asking about, though, is events. You can create custom events that identify all of those points that you're talking about, like, hey, user chose to click on this call to action, right? Or user, dropped item from their cart or things like that. So you could definitely use this for that type of information if you instrument your application properly. Okay, so there was a couple of other questions. Yes. Okay, how much can it slow down your application to have included all of this tooling? So I'm just going to go right up here. There is early in the documentation something about performance. So I thought it was at the very top of this page. It's apparently not, so it must be the top of a different one. Probably this one right here, overview. Oops. Like I said, basically it's negligible generally. I know there it is. Nope, that's small. What's the overhead? Here's the question, right? Impact on your application's performance is small. Now, if you're doing like high performance stock trace or stock trading, you could argue that it's not small. But I actually have never seen any impact on the application performance by doing this. I have not yet done the profiling and the call stacks. I haven't yet done those in production. Part of what you see today was a spike or a test to confirm how everything worked prior to using it in a production scenario. So perhaps those are a little bit more overhead, but in general, it's very good. As it says, they batch things, they sample things, they do work in background threads, and so far, I have no complaints, and I have used it heavily for about a year now, and quite heavily. Let's see. Okay, what would be the best tooling in Application Insights to build a developer dashboard for debugging application errors without requiring them to learn all of the Azure tools first? There's a couple of different aspects to that question that I would address. First, don't build a dashboard if you don't need to. Try to use the information that is here. If you can't find what you need, then reach out to Microsoft while you look for other options, right? So they can make improvements. The UI and everything it provides are very capable. However, if you do need to do something custom and you want to create a dashboard, then what you would actually do is you would just say, hey, I want to create a shared dashboard. And within those shared dashboards, it looks like I would need to create one here. But you can define queries that will populate the different graphs on your dashboard. So what I would do then is if it doesn't provide the information that I want, or for example, say I'm using those custom events and I want to know the click-through rate of certain things for an A/B test, right? I could write a custom query that would then be used to populate one of the widgets on a dashboard so that I have all of the information that I care about right up front. So there is a lot that you can do because all of this is built on the Azure Monitor infrastructure. So you have a consistent query language across all of your resources, and you can do a lot with it. Okay, so another question. So I use Blazor.WebAssembly for the front-end applications. Currently, Blazor.WebAssembly doesn't support application insights out of the box. Is anyone using it, using Blazor WebAssembly and using application insights with it? Okay, good question. I have not tried it. So application insights strictly makes HTTP calls. So in theory, you could take a look at what like the JavaScript SDK does, and you could emulate, or even the C# one if you really wanted, right? And you could emulate some of those calls and you could get that. That would be a pain. So I suspect as WebAssembly becomes more prevalent, that additional functionality will be added. And if anyone else has insight or has tried it, feel free to chime in. Okay, any other questions?
To follow up on the dashboard one, what if you need to build something for people who don't have Azure access?
Okay, so if we go back to application insights, let's see here. I think it's going to be under logs. Oh, no, it'd be here, streaming. You would want to stream the data. So I don't remember where it is here within the UI. I haven't needed to do this yet, but all of the data is sent to this log analytics backend, which is built on Azure Monitor. So each of these pieces can be configured, and you can see the columns right here. You can configure these to automatically be sent to other places, right? So I could send it to Event Hubs, I could send it to a storage account, I could do custom things, I could export it on a periodic basis. But if they're not going to have access within the Azure UI, you might want to look at that. Another option is back here where we talked about the API keys, is you create an API key for your application and you write queries that just call into the API to the backend. In other words, they can execute Kusto queries, these queries that I've demonstrated here, and you could then get those results and you could prop them, into, whatever, I forget the JavaScript one, but like 3D.js or something like that, right? Your JavaScript libraries for graphs and other stuff like that.
Yeah, thanks.
Yep. Any other questions?